So today, a new technique of integration. It's called integration by partial fractions. You will also hear it called fractional decomposition. Sounds a little organic, but that's what it is. We're going to start with, as I often do, introducing a new topic, something you know how to do, so that we can compare and see why do we need a new method. So start by, here's an integral. It's x plus 3 over x squared plus 6x plus 8. You already know how to do this one, so why don't you go ahead and pause the video and do that one and show how you would do it, and then we'll look at these. All right, so on this one, hopefully you've done it, and what you noticed is that the derivative of x squared plus 6x plus 8 is 2x plus 6, which is twice as much as that x plus 3 in the numerator. So this is a classic u substitution. We do a u sub for the denominator. Now, so this is a rational expression, and the first technique that you have for integrating rational expressions is doing a u sub with the denominator. So u is that, du is 2x plus 6. We want x plus 3 dx. Don't forget your dx there, like I just did. We want this to match the x plus 3, so we're going to go 1/2 du equals x plus 3 dx. Then we can go ahead and do our substitution up here. If we had limits of integration, we could change our limits, or we could keep the limits the same and sub at the end. We have a definite integral, so we're just going to rewrite. I'll put the 1/2 outside, and then this is my du, and this is my u. So I really just have that. All right, and then I know the antiderivative of du over u is ln absolute value of u, so I have ln absolute value u, my 1/2. Because I've done the integral now, I need to put the plus c now, and then I'm going to sub back my u, which was x squared plus 6x plus 8, so absolute value of x squared plus 6x plus 8 plus c, and that's my integral. Okay, fine, so that's what you know how to do. So what? All right, suppose, so look, this is x plus 3 over x squared plus 6x plus 8, right? Suppose it was x plus 12 over x squared plus 6x plus 8. Oh, then I would not be able to do that with a u substitution. I could try. I could say, and by the way, so what we're going to be talking about is all kinds of rational expressions. So a rational expression, maybe we'll put that as a vocab item. A rational expression is an expression of the form p of x over q of x, where p and q are polynomials. So that's a rational expression. So pretend that's an n right there. P and Q are polynomials. All right, so we're going to be looking at a lot of different kind of rational expressions. This is a rational expression that you can integrate with using a u substitution. This is also a rational expression. But if you try to use a u substitution, it blows up. If I try to use u equals the denominator, x squared plus 6x plus 8, then du is equal to 2x plus 6. So the problem is I cannot get 2x plus 6 to match the x plus 12. All right, if I try to do 1/2 du equals, I forgot my dx, equals x plus 3 dx. Okay, so what I can't do is like try to do something like, what if I do like plus 9 dx over here so that I could get the plus 12 over there? All right, can I do that, like plus 9 dx on either side? No, because then I have dx and du in the same expression. I mean, what am I going to have to do with 1/2 du plus 9 dx? What? Huh? All right, so basically, this does not work. Substitution does not work. Because in substitution, when we're algebraically manipulating the du to match what we have in the integral, algebraically manipulating our du to match our dx, you can only multiply and divide. Because if I multiply both sides by 1/2, I don't have that problem of a dx showing up on the wrong side. But if I try to add or subtract, I'm going to end up with a dx showing up on the wrong side, and it doesn't work. All right, so that sub doesn't work. So I need another method. Okay, so here's a different method. We need a new method. And spoiler alert, it's called partial fractions. All right, so here's the starting point of it. Do you remember how to add rational expressions, add and subtract rational expressions? If you do, tell me And if you don't, look it up. Or tell me that you don't know so we can schedule some flex time. What is 5 over x plus 2 minus 4 over x plus 4? Take a pause and tell me what that is. And then we'll come back and show how this can help us do this integral.